All right, here we go with the last part of the lesson on integration by parts. So a couple quick practice ones. You can try these on your own and then listen to how I go over them. You can just listen to me go over them. You can fast forward and say, I don't want to hear her go over them. But this is the way I normally start lessons, so I want to give you a chance to practice. So for the first one, your U has to be, let me get my pen going here. My U has to be natural log. Always, 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 if it's an integral, it's the U. Therefore, my dv is x squared. This is one of the few times it's kind of backwards from what you expect. You expect your u often to be your x's, but with natural log, we have kind of a difference here. Du is 1 over x. That's the derivative. V is the integral of x squared, which is x to the third over 3. Match them up. So we get x to the third over 3, natural log of x, minus the integral of these two multiplied together. When you do that, this x will cancel with one of these x's, so it'll be x to the second over 3. The nice thing about natural log showing up in your integral is you'll never have to do this more than once. I just integrate this one with a power rule, so this stays the same, x to the third over 3, natural log of x, minus power 1 greater would be the third power, over 3, it's already over 3, so 3 times 3 is 9, plus c. Second one is the one that I said is the most common on the AP test. It's the combination of e's and x's. That's a horrible, messy v, I'm sorry. Your u is always your x's. Your du is the derivative of that, which is just 1 or dx. Your dv will always be the e piece. When I integrate e, I get e, no adjustment because it's just an x as your exponent. So multiply these two together, x e to the x, minus the integral of these two together, which is just e to the x dx. Integral of e to the x is e to the x. So you have x e to the x minus e to the x plus c. Just a little recap of what we've done so far. I want to show you one more single term. So the last video ended with what do we do when you're integrating something that's by itself, but it's actually integration by parts. Again, totally sounds very opposite. The only time it happens is with natural log, which we've done before, and inverse trig. So with inverse trig, and there's a typo here. That should have an X there. Sorry about that. Inverse trig, it kind of acts a lot like natural log when it comes to integration. It has to be the u. No choice whatsoever. The dv then is just whatever's left, and in this case, you just have a dx or a 1. The derivative of arcsine is probably something you would have to look up because you haven't dealt with it in a while. It is du, which is the derivative of whatever's with the inverse trig, so the derivative of x is 1, over the square root of 1 minus that u squared. So we consider this to be like the u. I know that we're talking about u's inside of u's. So that's the form for inverse sine. V is the integral of dx, which again is like you're integrating 1, which is just x. So we've got these two multiplied together. So x arc sine of x minus these two multiplied together, which is x over the square root of 1 minus x squared. This, I do not need integration by parts for this. You might be looking at this and going, here we go again. This is actually just a regular u sub. Your u is 1 minus x squared. The derivative of 1 minus x squared is negative 2x. You have the x, you don't have the negative 2, so you're going to have a negative 1/2 adjustment. You already have a negative out front, so you're actually going to have a positive 1 out front. It is a u to the negative 1/2 because it's in the bottom being square rooted. So you end up doing power 1 greater divided by that power. So I'm going to write my final answer over here. So I still have my x arc sine of x. I'm going to run out of room. And then power 1 greater is the 1/2 power. Divided by 1/2 is the same as times 2, but there's already a 1/2 out front. We end up with a positive 2, and then u to the 1/2, which would be 1 minus x squared to the 1/2 plus c. Pretty complicated. The nice thing about that one is usually that is not one that shows up much on the AP test. Oh, sorry, the 2's not there. The 2 and the 1/2 cancel. Sorry. It's tough when you're doing these by yourselves and you don't have someone to interrupt you and catch all your mistakes. Try to catch them as I go. All right. So I promised before that there would be a shortcut. There would be a way to do this integration by parts shorter. And I also promised that there will be a way to know exactly what your strategy should be. So that's what I want to finish with here. I want to talk strategies and shortcuts. So here's strategies. So for our strategies, I think students need a way to say, okay, if this is what's combined, here's how I set it up. Because that's the toughest part of this whole process is knowing what should you be, what should DV be, how do I get it started? So I divided it into 3 types. Type 1 are the most common. So this is the type that's going to show up, I would say, like 75% of the time on AP problems or just any practice problems in general. Anytime you have X's combined with E's or X's combined with trig. With these, you're going to always let the u be the x part, whatever power it is, x squared, x cubed, just plain x by itself, 2x. Your dv is going to be the rest of it. So your e's, your sines, your cosines with whatever angle. Obviously, the more complicated the angle, the more adjustments, but you are going to have things that you know how to integrate, sine, cosine, and e. Your second type are your special type where you have x's in natural logs, x's in inverse trig, where your u has to be the natural log or the inverse trig. It's the only way I can integrate it, which means your dv is whatever was in front of it. So your x squared, x cubed, just plain old x, or absolutely nothing. This includes single term. So everything here is also like the single terms we've seen. This is probably going to show up maybe 15 to 20% of the time. Then you get your third type. Your third type is your cycling type. This was the type that is the least common on the AP test, thank goodness. You're going to see this maybe 5% of the time. This is the one where we have to do integration by parts twice. Once we do it a second time, then it turns into an algebra equation, and we are able to add that like integral to the other side. For these, it actually works both ways. I have just found, just from experience, I prefer to let u be the trig and let dv be the e piece. So that's just a nice summary sheet. This might be something you just kind of want to jot down, make a note. So anytime you see that, you can kind of look at this and say, what group does it fall into? And let's get started. So the second thing I promised is there's a shortcut. And this particular shortcut is only going to help us and only even needed with the first type of integral, the most common one, which is that type 1 where you have x's with e's or x's with trig. Anytime you have something like this, excuse me, you're going to have your u be your x's. So it could be regular x, it could be x squared, x cubed. The higher the power, the more repetition, the more I would have to do integration by parts a second time or a third time. If it's x to the fourth, I would have to do it 4 times, and that sounds awful even for me who loves to do math. So here's the shortcut. You actually make a table, which is why it's called the tabular method. In the table, you're going to have 2 columns. Your first column, I kind of did this one already for you so you can kind of see it, is your u. So you're going to put your original u piece, your x piece, and you're going to start deriving all the way until you get to 0. It's eventually going to get there because the more I derive a polynomial, eventually it's going to get to 0. So you could have a really big table if it's a high power. You could have a really short table if it's not. In your dv column, you're going to put the other stuff. It could be e, it could be trig. Every time with this column, you're going to integrate. So from here to here, I integrated. From here to here, I integrated. From here to here, I integrated. And you'll notice there was an adjustment every single time I integrated of a 1/2 in this one. Then I have to figure out, and I have this big table, what do I do with it? So the arrows here show how the terms match up. My first term is going to have these 2 multiplied together. My second term is going to have these 2 multiplied together. My third term is going to have these 2 multiplied together. And my last term is going to have these 2 multiplied together. I don't have to match anything up with 0 because when I multiply by 0, it's gone. Finally, we got to figure out what do we do with our pluses and minuses, because the formula is uv minus the integral of v du. So there's always this minus sign to worry about, that the more we do it, the more we have to distribute. Here's how we deal with that. Think of each term, so each arrow I drew, think of it as multiplying by a positive, which won't change it, and then the next one multiplying by a negative, which will change the sign, and then a positive and a negative. Always starts with the first term multiplying by a positive, meaning it will not change signs. It could still end up being negative if one of my terms that I'm matching up are negative, but when I multiply by a positive, it doesn't do anything. And then the same thing for the next one is a negative, and then a positive, and then a negative. So my answer for this one, my first term would be an x cubed and then a 1/2 e to the 2x, or you could put the x cubed on top of the 2. My next term is going to be negative, because I multiply by a negative, 3x squared over 4 e to the 2x. My next term is going to be positive 6x over 8 e to the 2x. And my last term is going to be negative 6 over 16 e to the 2x plus c. And if you want to go back and simplify fractions, you can. I usually don't because the AP doesn't care if I do or not, and I've done enough work. But that's your answer. If you don't use this shortcut method, and you don't have to, you would have to go through the integration by parts process 3 times and watch all your minus signs and your adjustments and your distributions without having this organization system. Personally, I love this shortcut method. I don't remember learning in high school. When I taught it to myself when I started teaching, I was pretty impressed at how quickly it would work. So here's one. We're going to go through the whole thing. If you want to set it up on your own and then start the video over, you can. So my table, my U is always my X piece. My dV is always my everything else. So sine, cosine, e's. Sorry, I wrote my table messy. Let me rewrite that. I want to put my U and my dV in there. Sorry. So I want to actually write U and dV first. I think that'll make it easier to read. So my U is x squared. My du is 2x. My next derivative is 2. My next derivative is 0. That tells me I'm done. Sine of 4x, the integral of sine is negative cosine. There's also going to be an adjustment because of the angle. It's going to be a negative 1/4 cosine of 4x. The other thing I like about doing it this way is it reminds me of my adjustments have to be done over and over and over again. My next one, when I integrate cosine, I get sine. It's going to stay negative, but I'm going to have another 1/4 adjustment, so I'm going to end up with a 1/16 sine 4x. And my last one, the integral of sine is negative, but it's already negative. So I'm going to end up with a positive 1 over the adjustment would be another 1/4 times 1/16 is 1/64 cosine 4x. Then I want to start matching up my terms. I'm going to do this in a different color just so you can see it. So these two will match up. These two will match up. These two will match up. Finally, as far as whether I multiply by a positive or negative, I'll go with a different color again. We're getting really colorful here. The first term is going to be multiplied by a positive, the next by a negative, and the next by the positive. Some people like putting them in front of those terms. Other people like putting it on top of the arrows. So my first term is actually negative because of this negative sign right here. So it's going to be negative x squared over 4 cosine 4x. My next term has 2 negatives, so it's going to be a positive 2x over 16 sine 4x. And my last term is also positive because there are no negatives at all, 2 over 64 cosine 4x plus c. So that's how the table works. I've even had students where they didn't have to use a table because it was just an x, not an x squared, not an x cubed. And they just said, well, the table is more organized, so I'm going to do everything from that type in a table. You cannot do the other types in the table. You can't. The shortcut doesn't help you at all. So if it's like x's with natural log, or if it's e's and trig, those types don't have that. The fact that the derivative won't ever go to 0, so I can't do it with those. So it's only helpful with this first type. Last one. This is one that the table method saves you so much time because it's an x to the 4th. I need to go back to purple. I miss purple. We're going to do, oh, that's a pretty one. So in my table, it's going to be kind of a long table. My u piece is going to be x to the 4th, and then 4x to the 3rd, and then 12x squared, 24x, my ability to multiply, hopefully, 24, and 0. So like I said, long table. Here's what's going to happen with my dv. It's e to the negative x. When I integrate, I'm going to get negative e to the negative x. When I integrate again, I'm going to be back to positive e to the negative x, and then back to negative, and then back to positive, and then back to negative. When I match them up, we'll go bright green now. These two will match up, these two, these two, these two, and these two. And when I look at my signs, what color do I want to do? I don't know why this is such a big decision. We'll just do blue. My signs are going to be positive, negative, positive, negative, positive. Here's what's going to happen. Every single one that I multiply together is going to end up with one negative sign. So every single term in this one's going to be negative. There's a negative here for the first term. There's a negative here for the second term. There's a negative here for the third term, here, and here. I have seen textbooks will actually factor that negative out. They'll even factor the e to the negative x out and just write all the u's. You can do that. I'm going to write it all out so you see it. So we get negative x to the fourth e to the negative x, negative 4x cubed e to the negative x, negative 12x squared e to the negative x, negative 24x e to the negative x, negative 24 e to the negative x, and then plus c. So like I said, every term has an e to the negative x and a negative, so I have seen AP problems that had that pulled all the way to the front. I don't need you to do that, but it is nice to recognize. So that is everything you need to know with integration by parts. We'll practice some AP ones that, of course, word things a little differently, but that is the gist of everything that's happening in this topic.